Everybody. I just wanted to give a quick introduction on how are some other ways that we can use tape diagrams other than the ways that we've been doing. So far we've used tape diagrams, which is just a long skinny diagram, like with our thermometers or our fundraising goals. And we've used them a little bit in the Crystal and Alexa gummy worm problems to represent problems. But tape diagrams are a really, really powerful tool that is really great for solving ratio problems. And the book doesn't go into a lot of detail on how you can actually use them, so I just wanted to give you some examples of how we can actually use tape diagrams to solve problems like the ones we've been doing with Crystal and Alexa. Tape diagrams and ratio tables are both really powerful tools that are really good to use. You may end up preferring one over the other, but it's good to know both. Okay, and actually it's one of the 6th grade content standards where you actually need to know both. You need to be able to use a tape diagram and you need to be able to use a ratio table to demonstrate sufficient understanding in 6th grade about ratios. So let's look at the problem, which is like our Crystal and Alexa problem. A group of students is working in a booth to support their community center. The amount of time each student works is in a ratio according to their ages. Abby is 16 years old, Kiaya is 12 years old. If Abby works 120 minutes, how many minutes does Kiaya work? How long do they work all together? So we know that their ages are in a ratio of 16 years to 12 years, okay? And we know Abby works 120 minutes. So in my first tape diagram, I've kind of drawn it all at once, but the first thing that I did was draw a big, long, skinny tape diagram showing Abby and Kiaya, right? Abby is 16, so I gave her 16 segments, and Kiaya is 12, so I gave her 12 segments. So then I decided, okay, I'm going to add another layer of my tape diagram up down here because I know that Abby has also worked 120 minutes, right? So Abby's section is also equivalent to 120 minutes. So I drew a bar that was as long as Abby and put in 120 minutes because 120 minutes goes with Abby, right? But I don't know, and what I'm trying to find out is how long, if Abby does 120 minutes and it's going to be in this 16 to 12 ratio, how long will Kiaya actually work? And that's what I need to find out. So I've got all these boxes. I've got these 16 boxes for Abby, and I've got these 12 boxes for Kiaya. And if I knew what was going to be in each one of those boxes, it would tell me how much Kiaya worked. So it'd be really helpful for me to figure out what's in one of those boxes. So if I go back over to Abby, right, I've got 120 minutes, and that's got to be equally distributed into 16 boxes, right? So 120 minutes distributed into 16 boxes. So I can write a division problem that allows me to solve that. And in this case, I wouldn't mind if you used a calculator, but I'm just going to do it out on my own here. So I've got 120 divided by 16, okay, which is not the world's easiest problem. And just because I like to, I'm going to rewrite it as a fraction, 120 over 16, because fractions are just division problems. And then I'm going to reduce. I'm going to say, okay, I know 120 and 16 are both divisible by 4. So 120 divided by 4 would give me 30, and 16 divided by 4 would give me 4. 30 and 4 are still also divisible by 2, so I'm going to go and simplify again. So 30 divided by 2 is 15, and 4 divided by 2 is 2. So now I've got 15 over 2, which is much easier than thinking about 120 over 16, 120 divided by 16. So 15 over 2, I know 2 goes into 15 7 times, and I'm going to have 1 left over. So it's 7 and a half, okay? So I know each one of these boxes, each one of Abby's boxes, right, is 7 and a half. So you can write it either as 7.5 or 7 and a half. And if I filled all of these in, right, 7 and a half, 7 and a half, 7 and a half, it would all add up, and I filled them all the way into the end and added them all together, it should equal 120. But now I know what one of these boxes is. I know it's 7 and a half, so I can use that in my section of the diagram about Kiaya. I know all of those are 7 and a half, so I could write 7 and a half in each one of these. It's going to take a little bit, but I could. And I know that I'm going to need, because Kiaya's has 12 sections, I'm going to have 12 groups of 7 and a half, right? So I could get my calculator out again. it's okay for you to use a calculator. I could say 7.5 times 12. So 7.5 times 12, I'm going to do 12 times 7, and then I'm going to do 12 times 1/2. I'm going to do partial products. Do it over here. 12 times 7 is going to be 84. 12 times 1/2 is going to be 6. Altogether, that gives me 90 minutes. So I know Kiaya has worked 90 minutes. And you may say, Ms. Shavik, oh, geez, that is a lot of drawing and a lot of work to solve one problem. And you're right, which is sometimes why ratio tables are better, right? However, a way to really simplify this problem is to kind of reduce the ratio beforehand before you draw a tape diagram, right? So if I'm looking at 16 to 12 and I go, wow, you know what, 16 and 12, those are both divisible by 4. Can I make this problem any easier for myself, right? So if Abby is 16 and Kiaya is 12, right, then I can reduce 16 to 12 to 4 to 3, and I can draw a new tape diagram where instead of having 16 boxes and 12 boxes, I have 4 and 3. This is still 120 minutes, but now I have 120 minutes split into 4 groups, and that's much easier. 30, 30, 30, 30, right? And then I know Kiaya has just got 3 of those boxes, 30, 30, 30, and I know Kiaya is going to be 90. So just doing a little bit of reducing ahead of time and simplifying the ratio ahead of time before I drew my tape diagram made my life a lot easier. So that's something also to think about. So this is just an introduction of how we can use tape diagrams to solve problems like this. You also can use ratio tables, but I thought learning about tape diagrams would also be good. Thanks very much. Bye.